Hello, Algebra 2 students. In this video, I'm going to work through a few examples to get you started on these problems. So in the first one, we are factoring out the greatest common factor. So you're looking for the largest number that you can divide both terms by, or sometimes it would be the largest variable that you can divide both terms by. In this case, they don't both have x, so I can't factor out x, but they are both divisible by 12. 12 is the largest number that they're both divisible by. And so I'm going to factor that 12 out. The number I factor out goes on the outside, and then after I divide by 12, that result goes on the inside. The second group of problems is factoring a trinomial where a equals 1. That means it's 1x squared instead of like 11x squared. The trinomial means it has 3 terms. So we're going to factor these by finding the numbers that multiply to c and add to b. So I just start listing numbers that multiply to make 100. Could be 1 times 100, 2 times 50, 3 doesn't work, 4 times 25, 5 times 20, and I'm looking to see, do any of these, if I add them instead of multiplying, give me 29? And this pair here works. And so the factors will be x plus 4 times x plus 25. Now, if you wanted to check and see if you did it right, you could multiply it out again. X times x gives you x squared. I have 25x and 4x. That makes the 29x. And then I have 4 times 25, which makes the 100. So I think I got it. In the next section, we are factoring the difference of squares. They follow this pattern. A squared minus b squared is going to equal a minus b times a plus b. And the reason that works is because when we multiply this out, because of the minus plus pattern, your middle terms will cancel out. So here, I want to rewrite this as squares. 25 is the square of 5, and x squared is the square of x. So if I square 5x, I get 25x. Minus 49 is the square of 7. So my a is 5x, and my b is 7. So it would be 5x minus 7 times 5x plus 7. All right, the next one is the hardest, factoring a trinomial where a does not equal 1. So in this problem, we start by multiplying the first and the last, the a times the c. And I'm looking for two numbers that multiply to make 33. And they're going to add to make negative 14. Okay, so 33, there's not a lot of numbers that multiply to make 33. 33 could be 3 times 11, or it could be 1 times 33. And neither of those are going to add to a negative number. So I also remember that negative times negative gives me positive. So now I can find these numbers here are going to multiply to positive 33 and add to negative 14. So next what I do is I split my negative 14x into two pieces, negative 3x and negative 11x. The 11x squared comes down, and the plus 3 comes down. So all that changed is that I changed the negative 14x to negative 3x minus 11x. I'm so sorry that that keeps going in and out of focus. All right, next you want to group the first two and you want to group the last two. I'm going to see if closing the blinds helps me. All right, so I grouped the first two and I grouped the last two, and I just want to put a little plus between these two so I remember that I'm really just adding these two sets of parentheses at the moment. They're not factors yet. I want to factor a common factor out of the first two, and I can factor out an x, and that gets me 11x minus 3, and then plus here, It looks like there's nothing to factor out. You would normally factor out a 1, but since my leading term is negative, I'm going to factor out a negative 1. And that will leave me 11x, and then minus 3, because negative times negative gives me this positive. And then my insides match. 11x minus 3, that's one of my factors. And that factor is being multiplied by x and by negative 1, so we're going to make that the factor. X and negative 1. That's done. All right, in the putting it all together section, we're going to combine these things. So you might need to first factor out a common factor, and then you're going to have to factor what's left inside. All right. Simplify multiplying and dividing rational expressions. So first you want to see what can be factored. So this one I can factor out a 2. And this one I'm going to start by factoring out a 4 and then continue. This one I can factor out a 12. I don't really have a lot of space for this one, so I'm going to make space for that in just a moment. Actually, maybe I'll use the space up here. If I factor out a 4, I would have x squared plus 2x plus 1. And then this will factor the numbers that multiply to 1 and add to 2 are 1 and 1. 1 times 1 is 1, 1 plus 1 is 2. So that 4 stays outside. I have x plus 1 times x plus 1. All right, so I'm going to bring down this one. 2 times x plus 1 over x plus 2. And then I'll change my divide to multiply, and I will flip my fraction. So this 12 times x plus 1 goes on the top, and this goes on the bottom. Okay. Now remember, when you're multiplying two fractions, essentially you are just making one big fraction out of them. So anything that's on the top can cancel with the thing on the bottom. And this one on the top can cancel with the thing on the bottom. And now I can multiply across. So 2 times 12 gives me 24. And then on the bottom I have 4 times x plus 2. 24 divided by 4 is 6, and so that gives me a final answer of 6 over x plus 2. All right, so you'll try the multiplication and division problems, and then we've got one more to do down here, and then you've got the rest to do. So I'm going to do this last one as an example. I'm going to find numbers that multiply to 10 and add to 11. So 1 times 10 is 10, and 1 plus 10 is 11. And then I need numbers to factor out here. 4 times x plus 9. Now, looking back at it, I realize that I actually don't want to factor my numerator when I'm adding and subtracting. So I'm actually going to erase that, because it's not going to actually help me yet. I'm going to factor later at the end if I need to. So, looking at my denominators, I have 4 times x plus 9, and here I have just x plus 9. So what I need is to multiply this fraction by 4 over 4 so that I have a common denominator. So now I have one denominator, which is 4 times x plus 9. And I'm going to bring this x squared plus 11x plus 10, and then 2 times 4 gives me 8, so plus 8. I'm going to combine my like terms there, so I have x squared plus 11x plus 18, and then I have 4 times x plus 9. Now is when I actually want to factor, because I want to see if anything will cancel. So, numbers that multiply to 18 and add to 11. 18 is 1 times 18 2 times 9, 3 times 6, and I think I found the numbers that add to 11. So x plus 2 times x plus 9. So the x, this is instead of this, and then x plus 9's cancel, and I get x plus 2 over 4. That's your final answer. So you should do all of the problems on this page, on both the front and the back.